Hi, I'm Mrs McTaggart, and in this video we're looking at the third level topic of angles, and today we're looking at what's called alternate angles, otherwise known as Z-shapes. So our learning intention is to be able to calculate missing angles using alternate angle properties associated with intersecting and parallel lines. Now, prior knowledge before watching this video is you should be aware of what two parallel lines look like. You might also have already seen that when two parallel lines are intersected, you create F-shape angles. And you should also be aware that any two angles on a given straight line should make 180 degrees. So let's get started. So let's explain what I mean by these Z-shapes. Whenever you've got two parallel lines being intersected by a straight line like shown, alternate angles are said to be equal, and we spot these by using Z-shapes. So this Z has created an angle here and an angle here that match. Now notice they are on alternate sides of the intersecting line. Alternate means you go from left to right to left to right. So my angle below the parallel line on the left has switched to above the parallel line on the right. Now Z-shapes don't strictly always have to be like as letter Z. So if I draw this same diagram again, there is also what's like an outstretched Z-shape going this way. And these obtuse ones on alternate sides of the intersecting line are also matching. So this is why the word alternate angles is used here, because it's alternating from left to right. Now we already know, hopefully from a previous video if you've watched it, is that these ones then also match because using opposite angles. And if you've already seen the F-shape angle, there are numerous different ways to spot all these different angles in this classic shape diagram. Right, let's look at some examples. So here is my first example. I have got two parallel lines with an intersecting line. Okay, the intersecting line stops, but let's highlight our Z shape. So here is my Z shape here, which should hopefully make the other 63 jump out to us. So this one in here is also 63. They are what I call on the insides of the Zs, alternate sides of the line. Now the only other angles I need to get are the ones that are beside the 63s, which are creating two supplementary angles, both making 180. So I now need to do 180, take away 63. And there's different ways of doing that. In this example, I would take away 60, makes it 120. Take away another 3, makes it 117. So these two missing angles are both 117. Notice that these 117s are also part of a Z shape, but it's an outstretched Z shape, or a kind of back to front one. Okay, so there are my missing angles in this one. Right, we're going to look at the other side. Now, I don't strictly have a Z shape straight away in this one. I'm looking at this as being my possible Z shape. So, I'm going to use a different angle property first of all, is that corresponding angles makes that 25 under the parallel line match up with that 25 under that parallel line. Then I can use my Z shape and get that bottom one is 25. Now I could have also got this bottom one first by using the fact that these two angles are opposite. Remember, there is more than one way to do these. Everyone sees angles in a slightly different order. So this one is 25. There is also one more 25 going on, which is up here. Whether I've got that by using my corresponding angles or opposite the other 25. It's a mixture of both. But ideally I used my Z shape there to start you off. Now all these other missing angles are all supplementary angles which make these two up to 180. Now 180 take away 25 is 160. Take away another 5 is 155. So all other missing angles are 155. Now you might be wondering, sometimes I put my angle sign in, sometimes I don't. I'm a wee bit forgetful at times. It's not the end of the world, but ideally it really should be in there. Okay, so this there, that one that I've just done is your most classic kind of missing angle question. And one thing to notice is these four angles down here that I'm circling match these four angles up here. They have literally just slid up the way or slid down the way. And if I was to draw in another intersecting line, then these four angles would also just slide up and match in there as well, giving me 25s in the acutes and 155 in the obtuses. Okay, so every time I would have another parallel line here, that same set of four angles would slide down. Let's try some trickier ones. So my example 3 is two parallel lines, and I've created a little triangle here as well. So here is the first Z shape I'm going to use. Now, I don't have any angles in that Z shape, so I might not use that one first, but what I can do is get the other one the side of this 100. 180 take away 100 makes this one in here 80. And then using that little Z shape, if that's 80, then so is this one. So there is my other 80. Now I have another Z shape going on. If I come and draw a Z this way, a back to front Z shape, which allows me to get the other angle of 40 being down here on the alternate side of the line. So far I've filled in those angles. The other one I can get is the one opposite the 40, this one here. It's on a straight line with 40, so it must be 140. Now the last missing angle up the top here, there are two ways to get it. If you know angles in a triangle, you can do it that way. Or we could simply look at this top line and go, all three of these must make 180. So at the moment I've got 120, so this one must be 60. And then my final shape is a parallelogram. Now in a later video I will do angles inside quadrilaterals, but this one essentially has Z shapes, so I thought let's do it. So here is my Z shape, which makes this corner up here inside my Z shape a 35. Now I have this exact same Z shape here again, slid down. Okay, I also have some corresponding angles going on. So this 35, this is a 35 down here above the parallel line, and this is 35 down here below the parallel line. So I've got two Z shapes going on and some corresponding angles. Now the only other angles left to find are the ones on the straight line with 35, so 180. Take away 35 leaves me 145. And this one here must be also 145. And it's worth noticing in the parallelogram that if you were to add up the corners, so if I added up this corner and this corner, collectively they make 180. And if I do the same with this corner and this corner, they also make 180. So actually all the sides in a parallelogram make 360. And notice the opposite ones match up either way as well. But that is for a later video. So this is a point where you can pause and try these ones. I would ask you to sketch and fill in all the missing angles. Remember, we are looking for our Z shapes for all of these, but other methods are possible. And if you unpause, you can check your answers. And I've kind of colour coded where all the matching angles have gone. So I hope this has helped. And thanks for watching. Bye bye.